Getting closer to Batman versus Superman.
Yes.
Getting closer.
No.
Yeah.
Yes.
We have what's it like?
It's
One
25th.
one day.
25th.
Yeah, 25th of March.
2 weeks on Friday.
Oh my God.
They have a new movie. Zootopia? I don't know.
Zoolander 2?
No,
No.
Zoolander 2. The cartoon.
What is it?
Zootopia.
Oh,
Yeah.
what is it?
Zootopia.
Zootopia. It's
It's
very
animation.
now it's very popular in China.
Yeah, very popular.
It's Superman?
No.
Batman?
It's the
From Disney.
cartoon.
What's
It's
it called?
it's an animation.
Yeah,
Zootopia.
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 Zootopia?
Yeah.
Yeah.
It's good?
Yeah,
I
they
don't
say
know.
it's good.
Have you seen it?
No.
My
Because
Chinese friends seen it.
oh, we can see it in the same day.
The same day with
In
Superman.
25th of
Ah,
March.
two movies at once.
Yes.
Great.
So maybe
But
later.
it's too late in here.
Yes, very late.
Anyways, I'll just go see Superman versus Batman.
You can see.
I hope it's
We
good.
recommend that the cartoon movie is good.
Which
Yeah.
movie?
Yeah.
Zootopia.
Okay, maybe I'll look at this too. Right, what lesson do we have the homework for?
Sometimes your teacher use blah blah blah.
Sometimes teacher uses blah blah blah. What are you talking about?
The question.
Oh! The question is teacher blah blah blah. Sometimes your teacher, yes, okay, alright. Blah blah blah, I understand. Right, why isn't this projector on now?
Oh, I don't know.
Me too.
Why you're here?
I need money. Right, come on projector, let's start. What's the problem? Come on.
You want to go home?
Yes, it does actually. Here we go. Right, sometimes your teacher uses a nickel coin when his batteries are too short for his toys. A nickel coin is 15 millimeters wide and 2 millimeters thick. How much resistance is added to his toy? So, what you have here, you have a coin made of nickel, and it's 2 millimeters thick and 15 millimeters wide. So the formula for the resistance is resistivity, length over area. Resistivity, 15 times 10 to the minus 3. No, yes, no. 2 times 10 to the minus 3 over pi or squared. Hareen or anybody, do you have the constant for the nickel? I gave it to you.
Oh.
6.99 multiplied times minus 8.
8. Okay, so we'll just hit this in on the calculator and we have our answer. Unless somebody has the answer already. Does anyone have this answer?
No.
No? What went wrong?
I got A and I forget to get R. I don't know what I'm thinking. I didn't homework.
Yeah, what were you thinking? So the answer is quite small. I got a tiny 0.79 micro ohms. Is that okay?
No.
What went wrong, Amanda?
I don't know. Maybe I misunderstand the
Okay.
wide and the length.
Okay. Next part?
Yes.
Yep. So, a student draws a very thick line on her notebook. The student runs a current through the pencil drawn. I can do this in class. And because, I'll do this in class sometime. because graphite is a good conductor, the current does not experience much resistance. If the line you drew was 10 centimeters long and the resistance was 0.5, then calculate how thick the pencil drawing was. Now this one is a little bit difficult to picture. If you have a pencil and if you draw a thick line on your page like this, believe it or not, you can pass a current through this. Now I'll show you this in class, it's quite fun to see. So what you do is you take a piece of paper, you take your pencil, and you draw a thick line on the page, and then you take positive, negative, and you put at the end, and it will go through the drawing. But if you move it off the drawing, like if I put it down here, then it doesn't move through the paper. It only moves through the pencil on the page. And this is because the graphite in the pencil is a good conductor. Maybe you did this in chemistry? No? No. So let's get the information here. So what I'm going to do now is look at the side. So when I look at the side, I tell you, what do I tell you? I tell you how long it is. 10 centimeters long. Yeah. Now what shape should we draw here? Like, I mean, when you look at the side here, so this is the page. Do we draw it like this? Like this? Or maybe like a square? I think you're right. I think it should be a square.
Square?
You said it should be a square, and you did... Okay. What? You were right. Yeah, why? Okay, so we'll make it a square. Okay. Now look, we need to estimate here. So we'll call each side x. But of course I know that maybe this side is bigger than this side.
Yeah, what is this? This is the graphite, right?
Yeah, looking at the side.
Okay.
And besides which, it's not really going to be a perfect square. It's going to be some weird shape like this on the page. So we'll just say, okay, we'll just estimate it's a square. So it's x and x. So what's the area here? X squared. Now I give you the length. What's the length? 10 centimeters. So you have the formula resistance equals rho L over A. We know the resistance. What is it? 0.1.
0.5.
0.5. What's the graphite constant? 5. 10 to the minus 6 times 0.10 over x squared. So what do I want to know? I want to know the x, isn't it? Yeah. So the answer is x is about 1 millimeter, roughly. Okay? Yes? Okay. Number 3, a bolt of lightning strikes a tree that is 30 centimeters wide and 3 meters tall. What is the resistance in the tree? So, number 3, for 3. There's the ground. And we have our tree. So the lightning comes along and it goes through the wood. So it's like this is a resistor. What is the resistance? Resistance is this over this. What is it for wood? It should be really big. What's this constant for wood? Yes? Amanda?
Huh?
What's the constant for wood? Do you have it there?
Constant of wood.
Yeah, the resistivity of wood.
1 multiplied 10 power 14.
10 power 14 times 3 over pi or squared. So it's big. Really, really big. Mega is 6, giga is 9, tera is 12, 4244 tera ohms. What's after tera? Hang on. Mega, giga, tera. What's after tera? Tera. Not zeta. Is it zeta? I don't know. Anyway, it's a lot. It's a lot. A lot of resistance. Okay. Number 4. Telephone company is laying down copper wiring. The copper wire is 4 millimeters in diameter and 2 kilometers long. What is the current running through it? When the current is running through it, then how much resistance will the copper wire offer? Would 2 wires braided together and not insulated offer? Right, so you have the copper wire is 4 millimeters in diameter. Okay. Yeah, actually I should have really said for the first one, when 2, yeah, sorry. It doesn't matter. So what I was picturing in the first one is you have copper wire and it's going to be, radius is 2 millimeters and the length is 2 kilometers, was it? So the resistance is, let's have a look, rho L over A. What's the constant, resistivity constant for copper?
1.72
Yep.
10 to the minus 8.
Yep. Times 2000 over pi or squared. So I get, not too bad, 2.74 ohms. Is that okay for the first part?
2.74. 73.
7374, yes. Yes. Okay, now in the second part what happens is the wires are braided together and not insulated. So if you look here, what happens in the second part is you have the wires, look, and they're, I can't draw braiding. None of the girls have their hair braided. Do you know what I mean by braided? Braid your hair? You know braid? You know not braided. When you have the 2 strands of hair and you fold them. To you know what I mean?
Yes.
Like this. Do you know what I mean?
Yeah.
You know this word. Yes. Do you know what I mean? Do you know what I mean? Okay, good. And Hareen?
Yeah.
Okay, good. So you have these two wires and they're braided together. So if you were to look at the picture, they look like this, and I'm not going to try to draw it, but they're wrapped around each other. But the only thing that's different here is what? Is the area is the only thing that's different. The area is twice as big. So if I make the area twice as big, what happens to my answer? Does it get bigger or smaller? Smaller. So here it'll be 1.37 ohms. Now I'm going to put in a part 3 here. Wait, actually. Yeah. So part 3, my extra part. Here the wires are not insulated. That means they're touching. Now what I'm going to do is insulate the wires. That means I'm going to put some plastic around it. So then they're not touching, they're protected. It won't be this anymore. It's going to change. Does anybody know what I would have to do? Well, if you think about it, the problem now has become like this. You have one really long wire, and then you have another really long wire. And I know they're wrapped together, but because they're insulated, they're not touching. So it's like this, just two wires. So what's the total resistance here? Well, it'd be this formula, wouldn't it? 1 over R1 plus 1 over R2. So that is 1 over 2.74. Why is it this? These two don't touch, so it's the same as like this. Because maybe here is some plastic. So they don't touch. So they're independent, they're separate. So that means R equals wait, is that right? I think I made a mistake. No, I guess not. Yeah. I didn't ask you to do that. Now the reason I didn't ask you to do that is because you didn't have that formula until the next lesson, which was the lesson on simple circuits, which we'll do now. Okay, you got that?